So our last example with finding the limits of difference quotients. Again, this case is a little bit different because we're dealing with the function square root of x. This is going to make this particular approach a little bit different, but the good news is whenever our function is a radical function, this approach will always be the same. So overall, this approach is quite a bit different than the other two, but for radical functions, we'll always use something very similar to this approach. So we'll start off by plugging in our function, so instead of writing things in function notation. So this is going to be the limit as h approaches 0 of the square root of 3 plus h minus the square root of 3 over h. So our goal is still to get this h in the denominator to cancel out. As this problem, stands, there's nothing we can really do to the numerator. We can't, pardon me, there's nothing we can really do to simplify that. So what we need to do is introduce something to our problem. And what we're going to introduce is the conjugate of this numerator. So what we're going to do is multiply by the square root of 3 plus h and the square root of 3. So the conjugate of a radical expression is always that exact same expression, and we just use the opposite sign in the middle. So since this was started off as a subtraction problem, we're going to make this an addition problem. And since we can't change our problem, we have to multiply by this. We have to divide by that exact same expression. So we're going to divide by the square root of 3 plus h plus the square root of 3. That way this expression divided by itself is just 1. We're not changing the original problem at all. We're just introducing some new information so that we can rewrite it a little bit. And again, we call this the conjugate of this original radical expression. So now what we'll do is expand this out and simplify. In the numerator, we're going to take this expression times this. So we're going to use the FOIL method to expand that out. We'll get the square root of 3 plus h times the square root of 3 plus h is just going to give us 3 plus h. Outside terms, we get the square root of 3 plus h times the square root of 3. Inside terms, square root of 3 times the square root of 3 plus h. And then our last two terms, minus the square root of 3 times the square root of 3, is going to give us negative 3. All over h times the square root of 3 plus h plus the square root of 3. So at this point, it might look like we've made this problem awful, but what we see is we've got two terms that are exact opposites of each other. So those two are just going to cancel each other out, which is going to leave us with the limit as h approaches 0 of 3 plus h minus 3 over h times the square root of 3 plus h plus the square root of 3. So in the numerator, we've got plus and minus 3, which gives us the limit as h approaches 0 of h over h times the square root of 3 plus h plus the square root of 3. So we kind of got to this intermediate step where things were looking awful and complicated. We get things to cancel out, and now h over h is able to cancel, so that h in the denominator is gone, leaving us with the limit as h approaches 0 of 1 over the square root of 3 plus h plus the square root of 3. And now we can revert back to direct substitution and evaluate this as 1 over the square root of 3 plus 0 plus the square root of 3, which is going to give us 1 over 2 times the square root of 3. Again, you could plug this into your calculator, get an infinitely repeating decimal answer, but for these theoretical problems, unless we're dealing with an application problem, we want to leave things as exact results.